I'm Nick Clark. I'm the Agronomy and Nutrient Management Farm Advisor for UC Cooperative Extension.
Hello, my name is José Luis. I'm the Agronomy and Weed Management Advisor.
Here we're demonstrating a nitrogen decision management tool for the grower. Right now we're in a central area of Kings County, California, a geographical region called Tulare Lake Bottom. It's a fairly uniform, relatively speaking, in terms of environmental and soil conditions. It's highly productive, and there are pretty predictable crop rotations in this area. Right now we're standing in a triticale seed production field. In this field, in this region, some of the things that hinder their stand establishment is, there are some salinity and acidicity issues that might hinder soil-water relations with early plant establishment. They also have pretty big onflows of water by virtue of their irrigation management that's typical in this area. So we do see some visible gradients in plant soil water relations from the head of the field down to the bottom. That might also be a source of variability. In this field, one of the decisions that the grower was trying to make at planting was timing, and the timing was relative to the water management. They had some irrigation water that they would be able to take advantage of, so they made the decision to drill this crop in. It was irrigated up with about 7 inches of water 10 or 11 days after they drilled it into the ground.
What are some of the recommendations when you are planning to establish one? Is there a specific recommendation in terms of which location of the field should we pick or should we avoid, and how many should they have per area depending on the size of the field?
When we're picking locations in the field to place the nitrogen-rich reference zones, one consideration is certainly the size of the field, but more importantly is the representative variability in the field. We use tools like grower input. They might have some aerial imagery that they already have paid for from another commercial supplier. They might have yield mapping. We use the soil survey web tools to look for patterns in productivity over the years. And when we have all of that information and we're confident that we have a good idea about what the variability within the field looks like, we can then imagine what different zones of productivity would be within the field, and we then make sure that we're placing our nitrogen-rich reference zones in those different productivity areas of the field to make sure that when we're getting reference measurements between the nitrogen-rich zone and the grower zone, that we're accounting for the natural variability across the field. We noticed early on in our decision making about where to place these reference zones that there were some obvious differences in plant productivity, particularly pronounced on the western portion of the field where we're standing now. And what we observed earlier is that there's significantly reduced stand density of the plants relative to where we're standing now. I technically have 3 nitrogen-rich strips in this field currently in the plots that we laid out. We have one that we laid down immediately after drilling in, and then one that we laid down a week later, and those two overlap each other. So we have one quadrant in the field where there are 120 units of nitrogen per acre applied. When we made the first assessments, the stage of growth that the crop was in was tillering. There were about 3 to 5 tillers on the plants at that point. About 3 weeks ago for this last fertilizer application and the time leading up to it. That we were able to get out and collect some soil samples from the bulk field and evaluate the soil nitrate levels and confirm that they were pretty low. That's what we expected, considering there was no pre-plant nitrogen fertilizer applied, and then from previous pre-plant soil nitrate samples, we didn't expect it to be very high. The plants in the grower managed portion of the field, there was a likely plant deficiency signal between the nitrogen-rich zones and the rest of the grower's managed field. Really quickly use that data as input into the nitrogen management web tool in order to calculate, and some of the grower input in terms of planting date and location, in order to determine what a nitrogen response curve would look like. And based on this grower's expected yield was about 7,800 pounds of grain, and with low importance on protein because it's going to seed, we anticipated that they would have a positive and significant yield response to about 90 pounds of nitrogen per acre. We were able to get that information to the grower in a actionable time. They were just about to purchase their fertilizer. They ordered that much. They flew the urea on by plane, and here we are now trying to assess the efficacy and the impact of that fertilizer application. After we made the recommendation and the grower followed up with a fertilizer, or was planning to follow up with a fertilizer application, what we did in order to try and assess the effectiveness of our recommendations and the grower's application of fertilizer was to come out right up close to the application right before it and tarp off an area with stakes to create an exclusion zone, or essentially a low nitrogen control zone, where we could then have two areas in the field to measure where we would be able to detect differences in plant response and productivity in yield as a direct result of the application of fertilizer. So we'd have that basis of comparison there. Today we're harvesting and measuring some of the effects of the fertilizer decisions that were made in the field using the nitrogen-rich reference zone and the decision support tool. Last time we were out here, the grower had just applied 90 pounds of nitrogen to the acre as a granular urea ahead of a rain, and we had put out some nitrogen exclusion zones with tarps. And after that application, around the beginning of March, the grower was interested in irrigating, and we used the Green Seeker handheld NDVI and combination of aerial imagery to measure the plant nitrogen status in the reference zones compared to the grower managed zone, and determined that the field was in need of about 50 pounds of nitrogen to the acre. And at that time, the grower decided to follow up and accept that recommendation. They applied 50 units of N as a combination of ammonia and UAN 32 run with the irrigation water about 5 inches. Later in the season, when the grower typically finishes off the last irrigation, about 30 pounds of nitrogen as ammonia around heading time. We came in just ahead of the irrigation using the at-leaf chlorophyll meter and a combination of aerial imagery again, and with the data that we collected at that time and run through the decision support tool, determined that there was not a need for any more nitrogen fertilizer. Communicated that to the grower, and they agreed, and they saved that application
and just put on a regular irrigation at that time. Today, during harvest, we've taken some hand harvest samples of the exclusion zones and the growers managed portion of the field and the nitrogen rich reference zones, and determined that the difference in yield between the nitrogen exclusion zones, so where they did not apply the 90 pounds of nitrogen per acre with that first fertilization, compared to the grower management zone, was about 12 to 15% less in terms of grain yield. So that was very close to what we predicted would have been gained from that application. So we're satisfied with what the model told us, and we're happy that the grower is able to follow our recommendations, and we're estimating that the yield in this field is probably close to 4 tons. So application of nitrogen, well worth it. Yeah, so I think all in all, the general outcome of working in this field with this grower was pretty good, in that they're already pretty progressive wheat growers, in that they split their nitrogen applications multiple times within the season, and they focus most of their applications post-plant, when the crop is more likely to utilize that nitrogen more efficiently. So we had multiple opportunities this year to get in ahead of rain and irrigations, to use the handheld tools for measuring plant nitrogen status, and using aerial imagery with drone and satellite, measuring the nitrogen status in the reference zones in order to put that data into the nitrogen decision support tool and get a very clear-cut recommendation each time in a really quick turnaround to the grower, so that they could actually use that information and make action. It was actionable information. They were able to make decisions based on it. Withhold an application of nitrogen, or adjust the rate of nitrogen that they were going to apply. So I think that's probably the best outcome, is that we can get good information quick, on the fly, and it's reliable. We're all very grateful for the time and effort and attention that these growers have put into this demonstration. This is year 2. Since the first year, they've gotten even more involved, intellectually and hands-on in the decision support process. And we're very grateful to be out here on this property and working with them.